So Ritvik, you're able to share screen?
Yes, sir.
Okay, awesome.
Let me know once it's visible.
Yeah, it's visible.
All right. Good morning, everyone. Welcome to another session on blockchain. Today, we'll be discussing about the various types of blockchain and why we decided to go ahead with Flow blockchain while we were building FloCard. So let's get right into it. So last time, since we discussed a lot about what blockchain is, how it is different from our conventional databases, today we'll be discussing about the types of blockchain. So if we categorize it generally, we can say that there are three types of blockchain. There is a public blockchain, private blockchain, and consortium blockchain. So now, as the name suggests, public blockchain is just like our regular blockchain. Every node has the ownership of the ledger. Every particular node, every particular system with an internet connection can become a node, become a participant, and become a supporter for that particular blockchain. In private, it's not just that you have a system and an internet and you can just contribute to that particular blockchain. You have to have an invite. So this is a private blockchain where it is still following the exact same rules of the blockchain, but the nodes cannot be anyone. So the validator and the node providing and all the other nodes, they are a part of blockchain only when sent an invite. So only the invited participants can be a part of this private blockchain. Then there is consortium blockchain, also known as hybrid blockchain. So this is a type of blockchain which has a mix of public and private blockchain. So in consortium blockchain, what we can basically say is that there are few nodes which are public, there are few nodes which are private. So there are some particular forks of that particular blockchain which can be private. So everyone who wants to commit to that particular iteration will have to have an access for the private blockchain. But let's say if we just go from the main line, which is the public blockchain, it is still go ahead and you can just do it like a normal public blockchain. You can start contributing. Let's have a little deeper understanding of what these type of blockchains are. So let's start with the public blockchain. So as you can see in the image, all are validators. So as you can see, there are 1, 2, 3, 4, 5, 6, 7 of the CPUs placed on any part of the world. These are all part of the same blockchain network. These all have a common ledger. Every time a node gets updated here, everyone gets a new ledger. We discussed it last time on how this ledger gets created and how they are getting attached to that particular blockchain. So a public blockchain does not have any restrictions. Anyone with an internet connection can get access to the network and start validating blocks and sending transactions. Typically, such networks lead to offer some kind of incentive for users who validate the blocks. So this is what we discussed last time as well about the minings. When you mine something, you validate a block, you get some reward. So that's based on the public blockchain. Anyways, so this network tends to use proof of work or proof of stake consensus algorithm for validating the transactions. It is a public network in a true sense. It is the model that Satoshi Nakamoto, the owner of Bitcoin, suggested back in 2009. You can call it the mother technology. Later, enterprise companies started showing interest in blockchain technology and tweaked the nature of the decentralized ledger and introduced the private blockchain. In public blockchain architecture, you can download the protocol anytime and you will not need any permission from anyone. The public blockchain portrays the ideal model that makes the technology industry so lucrative. Thus, it's completely decentralized. No single organization controls the ecosystem, whereas a private blockchain can be changed and altered by the owning organization. A public blockchain surpasses the necessities of third party. The system has a natural flow of its own, just like flowing river. So no one can control the flow path, yet everyone uses it. So how can you define it easily? So I can just go ahead and say a self-governed, purely decentralized and autonomous digital public ledger. It's like the definition of democracy, of the people, by the people, and for the people. So what are the key features of a public blockchain? So every node has an access to read and write on the ledger. Anyone can download and add nodes to the system. The technology is fully decentralized. It offers anonymity, which means that no one can track your transaction back to you. It's a bit slower compared to the private blockchain. It has truly decentralized structure, and it promotes the user empowerment. So you don't have to be constructed, you don't have to be holding yourself back if you want to contribute to a public blockchain. So that's why, and there are many examples. So the two most famous examples of public blockchain are your Bitcoin and Ethereum. So this is basically your public blockchain for you. And there are lots of applications which get built on top of public blockchain for a lot of other reasons. We'll get into those details in the later part of this session. Let's have a look over our private blockchain. So a private blockchain, in the first place, in simplest terms, a private blockchain is a type of blockchain network where only a single authority or organization has control over the network. Yeah, it seems like it doesn't directly resonate with the main concept of blockchain now. Well, even though private blockchain, the examples may seem like centralized network, in reality, it can offer partial decentralization. So in a network like this, you can't get an entry without any reason. In reality, this type of network is far suited as the internal technologies of an enterprise. You might be wondering why. So it is because as everything is dependent on technology nowadays, the previous ones simply can't keep up with the changing times. As a result, there are lots of issues such as data theft, identity hack, and so on. Therefore, to safeguard a company's sensitive information, using private blockchain is the perfect option. So without proper authentication, no one can enter this type of network. To make sure that any company can use blockchain, there are many blockchain companies that are working towards bringing a private version just for the sake of secrecy. For example, Ethereum used to be solely public platform, but now it is bringing Ethereum private blockchain with the same features and additional privacy for those high-end companies. Why should one consider a private blockchain? So it is of full privacy. In reality, a private blockchain platform focuses mainly on privacy instead of full disclosures. So if you are interested in technology where privacy is the greatest concern, then private blockchains are surely for you. On the other hand, an enterprise needs security and privacy because they always deal with cyber attacks. Also, as they are dealing with sensitive information all the time, it makes it difficult to keep everything at bay. Thus, if a company can use a private blockchain to tighten up its security facilities, then it will be impossible for any hacker to hack into the system. The other part of another good reason why one should consider private blockchain is the efficiency. So this type of blockchain platform offers the highest level of efficiency. In reality, private blockchain examples can show you how they work much better than traditional blockchain platforms. But why? Well, it's because in private, only a handful of pre-authorized nodes gets an entry. So there is no way the nodes can take up more resource than usual. But in a public blockchain, there are no limits to the number of nodes. As a result, the system shows down drastically when there are too many participants. But the private network is immune to that issue. Well, of course, it will be because the nodes which are involved in that particular blockchain are the ones who come from a particular source. So basically, they are invited nodes. And every item which has to go inside the blockchain, it is coming through all those secure channels already. And the traffic can always be handled based on the number of entries. So you don't have to rely on other people or a mining pool, setting up another mining pool with someone third party to just get your part done. Then there is another good thing
good
about...
morning, Rajesh sir. नहीं तो आप कल रात में थोड़ा सा ये होते होते तो थोड़ी देर हो गई, तो आप भी नहीं किए तो हम सोचे ऐसे छोड़ देते हैं, आप सोने देते हैं.
Mr. Sanjeev Sinha, you are...
नहीं, ठीक है, कर लीजिए. हम तुरंत आप कितने आज क्या आपका प्रोग्राम है?
Administrator, can you just mute here? Thank you.
हाँ, फ्री है ना आज? अच्छा. हाँ, तो अच्छा, तो हाफ एन आवर के बाद करें क्या? एक
इसका बात सुन लेते हैं ऋत्विक का।
हाँ, एकदम हाफ एन आवर में तो अच्छा से बात करते हैं, अच्छा लगा। ओके 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 ओके।
Okay, so another.
Just wait a moment, please. Mr. Sanjeev, would you mind muting yourself? We can hear all your conversations. Or admin, if the host can actually remove him, if that's okay. Yeah, thank you. Sorry, Ritwik, for that interruption.
Yeah. No worries. Okay, so another perk of private blockchain is scalability. So actually, private platforms are more scalable, more stable, and you will get the best performance out of it. The same goes for scalability. For a business to work efficiently, it should be scalable. So with time, it has to grow as well. But in a public blockchain, when the network starts to grow after a certain time, it starts to slow down as well. This is called a scalability issue. But private network seems to be past this issue as it can grow, but not slow down in any case. So when you use this, you can have a reduced fees for every transaction, faster transactions, and so on. Another perk is no illegal parties. So this is one of the key benefits of a private blockchain, as it does not offer any scope for any unknown third party to enter the network. Thus, it makes sure that no one can use the channel for their illegal activities, unlike public blockchain. Private blockchain can take this issue seriously as it can hamper the reputation of the company. So let's say a bank deals with a lot of sensitive information and they want to get on a blockchain, but they don't want the information to be public. So this is one of the way they can go forward with it, a private blockchain. Now we'll discuss about the third type of blockchain, which is our consortium blockchain, also known as the hybrid. So as federated blockchain or consortium blockchain or hybrid blockchain, where instead of only a single organization, multiple organizations govern the platform. It's not a public platform rather than a permissioned platform. More so, it's quite similar to private blockchain as well. But how are they different? Well, even though it's permissioned, meaning that you have to be a member of any organization with access to the ledger, it still would offer you decentralization. How? It's easy, really. So in private blockchain, there's only a single organization on the platform. So it's kind of seems like a centralized entity. However, in this blockchain, so multiple organizations can actually make decision on the platform. So there's no way that any organization can get away with any unauthorized activity. Every organization on the platform will have to agree to it. So basically just agreeing to the consensus. So just how we discussed in blockchain, every node will get an updated copy of the ledger. And if it is, once that particular block is getting verified, if it fails, if it doesn't follow the regulations, it won't be committed to the blockchain. So there's no way any organization can get away with anything. So the whole concept of consortium blockchain came to be the help of enterprises collaborate with each other in a way where there is no room for cheating your partners. So in reality, there isn't a single authority who holds that blockchain. Instead, every organization is committed in that particular blockchain, multiple organizations, and every one of them are agreeing to the terms and conditions every time a new block is added. So if they can contribute to the network and get credits and features equally, so they would all agree to get on that blockchain, because they are all getting the credits and they're all getting the features at the same time. It provides a collaborative environment, means more exposure and innovation as well. And this is the best part for all the parties in the system. So let's take an example. And what type of companies can go forward with it? So a company which wants to share information with the other clients, with the other organization, they want to collaborate on a new build of something, and they want to share those information based just on that particular whatever they are coming up with. Let's call it a device. Let's say they are making a device and they all want to contribute, and at the same time they don't want someone else to be getting a go ahead, like using their information and not giving out the same level of information. So what they can do is they can collaborate on the consortium blockchain, and every time a new update comes to the device, it gets committed to the blockchain. So now every participant in that blockchain has an upgraded copy of where that particular device is at the moment, what that state of that device is. So what are some key features of this particular blockchain? First of all, it would be the faster speed, because the consortium blockchain will always try to offer the fastest output compared to the public blockchain. Usually public blockchains tend to become slower due to excess number of users on the platform, but not consortium blockchain. In consortium blockchain, you'll always get a better experience, but how? Well, as the platform is permissioned, not anyone can get access to it. So there is always going to be control over how many users are active in the same time on the network. Thus, the scalability issues are not prominent here in any way. So since you always know the number of people on this particular blockchain, so you don't have to worry about the scalability. You can always scale up based on the number of your users, which brings us to scalability itself. So why are there not a lot of issues with the scalability? So a consortium blockchain will always control the number of nodes for validating purposes. So you just can't expect to join the network, just get access to validating the transactions. And more so, there's always going to be selected node to maintain these kind of features of the platform. That's why you won't see any issues with slow network outputs or delayed transaction processes. Then there is low transaction cost. Another cool advantage of a consortium blockchain is the low transaction cost. Consortium blockchain providers will always offer platform in a way that offers low transactions for you. If you are getting a solution for these consortium blockchains provider, then you can outline the transaction fee as well. In many cases, the public blockchain gets far behind the system as more users come into the network and hog up the processes. As a result, the transaction fee keeps fluctuating at a rapid rate. However, in consortium blockchain, everything is regulated. So the transaction fee stays the same no matter how many users are on the network. Thus, it's a great choice for enterprises as well, because they'll get cheaper pricing compared to traditional banking schemes. There is one of the major key feature of this type of blockchain is, we had slightly discussed this in the last session. It is the no risk of 51% attack. So the 51% attack is basically when 51% of your nodes, the nodes which are clearing your blocks, which are validating your blocks, if the 51% is being held by one party, then they can just overtake the network. They can just change the rules and change the rules for any block getting committed to the network. So why does this consortium blockchain has no risk for 51% attack? This is because the blockchain does offer a greater level of security, but the 51% attack is a deadly issue. Usually in 51% attack, it would mean that more than 51% of the users on the platform are from a single organization or company. So if they want, they can take up all the computational power of the system and override any other transaction or even reverse the transaction process. However, in the federated blockchain, or your hybrid blockchain or consortium blockchain, that's not the case. As you would have to go through proper authorization first, you won't be allowed if you pull something like this. Also, as there are multiple participants, multiple companies, pulling it off is a bit tough. So to get multiple companies to go ahead with your idea, it is going to be different. But yes, the risk of 51% attack is very minimal, but it is never that it cannot happen. Let's say you are working with 3 companies and 3 of you agree to be on the consortium blockchain. 2 of them agree to kick you out, then yes, they can do that. They can go ahead and change the blockchain rules over there. So now let's look over a few examples of all these 3 types of blockchains and what are they based on. So we know that there is a Solidity. It's a language that we use to write our codes for our so we use it to write the, sorry, I keep forgetting. Okay, I'll just get back to it. So there is another, so when we talk about private blockchain, there is a multi-chain blockchain, which is being used by SAP Cloud Platform Blockchain for providing the blockchain services. Then there is a Hyperledger, which is the platform which offers the Hyperledger fabric. A lot of banks nowadays are using it, and to ensure that their information is safe, even though they want to use the public blockchain in a private way. So they have their own particular fork based on their public blockchain, and they have used. Why you would want to fork your from the existing one? Because there are lots of software which is built on top of those platforms which provide the proof of work. So then there are platforms like Bitcoin and Ethereum where the Solidity is built. There is also one Flow blockchain, which is on top of which our FloCard is built. So let's now that we know that these are the type of softwares which can be built upon the platform, how are they being built? I mean, on what basis are they being built? So let's have a look over that. So for that, we need to understand the fork in a blockchain. So what is a blockchain fork? So the decentralized nature of public blockchains means that the participant of the network must be able to come to an agreement as to the shared state of blockchain. Well, unanimous consensus amongst the network nodes result in a single blockchain that contains verified data and that the network has asserted, and they say it's correct. However, many times the nodes in the network can't come in unanimous consensus regarding to the future state of the blockchain. So this event leads to forks, like a tuning fork used in an experimental science, meaning that point in which the ideal single chain of blockchain blocks is split into two or more chains, which are all valid. So this gives rise to the three types of forks, which can occur based on the backwards compatibility of the blockchain protocols and the time instant at which a new block is mined. These types are soft fork, hard fork, and temporary fork. So in the shortest way, we can say a soft fork is when the blockchain protocol is altered in a backwards compatible way. Hard fork would be when the blockchain protocol is altered in a non-backwards compatible way. Temporary fork would be when two miners mine new block at the same time. Now let's have a look over these three types of forks in a slightly more detailed way. So for soft fork, when there is a change in the software that runs on the nodes, better called as full nodes, to function as a network participant, the change is such that the new blocks mined on the basis of new rules in the blockchain protocol are also considered valid by the old version of the software. This feature is also called as backwards compatibility. So there was, let's take an example. So the Bitcoin's network SegWit update added a new class of addresses, BEC32. However, this didn't invalidate the existing P2SH addresses. A full node with P2SH type address could do the valid transaction with a node of BEC32 type address. So these are the two types of addresses which were being used in blockchain right now. So then there is a hard fork. So when there is a change in the software that runs on the full nodes to function as a network participant, the change is such that the new blocks mined on the basis of new rules in the blockchain protocol are not considered valid by the old version of the blockchain, old version of the software. When hard forks occur, new currency come into existence with valid original currency. Like in the case of Ethereum, so original would be Ethereum. Then there was this Ethereum Classic, which was the new one, which is based on the hard fork. Then for the Bitcoin as well. So original one was known as Bitcoin. The new one is known as Bitcoin Cash. It's also a hard fork on the blockchain network. Equivalently, the quality of currency is distributed to the full nodes who choose to upgrade their software so that no material loss occurs. Such hard forks are often contentious, generally conflicts in the community. The final decision to join a particular chain rests with the full node. So if chosen to join the new chain, the software has to be upgraded to make newer transactions valid while the nodes who do not choose to upgrade their network continue working on the same. So let's say if you were mining Bitcoin, and if you were mining the original Bitcoin, which is known as Bitcoin. So, and then there was this new fork, which was Bitcoin Cash. So you have a node which is mining Bitcoin right now at the moment, which is validating all the blocks. But let's say you want to get on the Bitcoin Cash now. So you have mined enough Bitcoin, now you want to move. So what you need to do is you need to upgrade your software of mining to make sure that now you have enough resources to mine the Bitcoin Cash, which is basically validating the new blocks in the hard fork network. So another example is the new Casper update in Ethereum blockchain, in which the consensus protocol will change from the type of proof of work, POS, to a type of proof of stake. The nodes which install the Casper update will use the new consensus protocol. Full nodes that do not choose to install the Casper update will become incompatible with the full nodes that do. Basically, they'll just be mining the earlier version. So earlier version, if there is a new block getting committed, it will be validating those blocks. But let's say if someone, so let's say your node is around here, and you were validating these blocks in the main blockchain. But let's say you want to come and start mining the other ones, the new forked ones. So what you need to do is you need to upgrade your software and start contributing in this particular chain now. And if you want to go back to this, of course, you can roll back to the earlier version of your software and go back to the mining these and add validating the blocks. And it's just based on what you have chosen to follow from there onwards. The third type of fork is a temporary fork or an accidental fork. When multiple miners mine a new block at nearly the same time, the entire network may not agree on the choice of the new block. Some can accept the block mined by one party, leading to a different chain of blocks from that point onwards, while others can agree on the other alternatives of blocks available. Such a situation arises because it takes time, some time to add the block to the blockchain, in which the conflicts can occur. So, and once the conflicted opinions can exist regarding once the conflicted opinions can exist regarding the chronological order of the events. So in this fork, two or more blocks have the same height. Temporary forks resolve themselves eventually when one of the chain dies or gets orphaned. In the blockchain world, it's called as getting orphaned. So because majority of the full nodes choose the other chain to add new blocks and sync with it. So let's take an example. So temporary fork happens more often than not, and a usual event that triggers this fork is mining of a block by more than one party at nearly at the same time. Now, this type of issue usually occurs in a public blockchain. Why? Because there are n number of users, there are n number of miners, there are n number of validators. They're all validating at the same time. So yes, there are times when the two blocks are trying to mine the same, two nodes are trying to mine the same block, and they eventually end up validating because the transaction is correct. It's not that the transaction or the block they are mining is wrong. It is correct. So they have mined it. Now there are two chains of the same blockchain. So eventually at some point, what the blockchain would do is one of them would die, because let's say if the miners stop, let's say there are three miners right here. The two decided to go ahead with the one decided to go ahead with this, and the two decided to go ahead with this other chain. It is the same chain. It's just that it has a slightly different path. But let's say if this one miner stopped at some point and the other two continued, so this new block is getting committed and this block will die out. And let's say if this old miner starts to mine again, so what it would do is it would go back, start checking all the chain again. If this chain stops here, it can just go ahead and check which chain has the latest number of blocks. Once they find the latest number of blocks, they can go ahead and start adding the information in that particular block, in that particular chain. So now that we know, we have a good idea of what the public, private, and protected blockchain are, what the types of forks are. Now we'll discuss one of the other items on our agenda. It is why FloCard is built on Flow blockchain. So when we talk about this, there are multiple reasons. So first of all would be our 40-second block time, which basically means that you can mine a new block is getting added in every 40 seconds. The low cost of flow coins, making the transactions less costly and more effective. Flow blockchain allows us to add 1040 bytes of plain text as a part of every transaction that can be used to commit data in plain text or as protocol information on blockchain. Fork of blockchain like Bitcoin and Litecoin gives it a proven algorithm. What is Flow? So let's quickly have a look over what is Flow. So Flow is a public record for building decentralized applications that introduces a new feature called floData. This metadata layer allows reading and writing to the blockchain quickly and easily, encouraging unique apps and tools to be built with Flow. One of them would be our FloCard. It is a script mineable cryptocurrency with quick transaction processing. So with 40 seconds of block time, it is based on the Bitcoin and Litecoin source code. With improvements in several areas, Florin Coin also introduces a new useful feature, transactional comments. These transaction comments enable Florin Coin to facilitate a number of unique applications. So it was built in 2013 with a total of 160 million coin supplies and the transaction comments of 528 character. Now, why is this important? Let's say you want to find a specific transaction and let's say you want to select all the transaction mined on your particular application on Flow blockchain. So you can just go ahead and if you have added a key value to those comments, you can just search it up. And it has a 800,000 block halving. So what is block halving is, let's say once a user has mined a certain amount of 800,000 blocks. So what it would do is every time you mine a particular, every time you validate, you are getting rewarded with the coins, right? So once you have mined around 800,000 of blocks, because there is a number of coins which is limited to the blockchain, what it does is it reduces the amount which you were getting rewarded for every validation of validating every transaction. So Flow blockchain, there are multiple applications which is built on top of Flow blockchain. So when I talked about the characters, addition of characters, let's just quickly have a look over how they look like in person. So let me just quickly show you. Okay, so I have logged in with my FloCard. Okay, I'll just quickly log in with my Google ID. Okay, so now you can see that I have two cards of mine, and then there are these types, right? So let's say I viewed a transaction. So you can see there is flowsite.duckdns.org. This website, it shows my transaction ID. It shows the block we are being built on and the comments which were added. So this is the comment. As you can see, it is of FloCard. We added that and whatever the value was, we can use those. But let's say how we are dividing the type. So let's say for exchanges, we are using exchange. Then there are for creation, registration, updates. So we can add these comments to our existing transactions to make it more suitable for what we are building. So what we are building here in FloCard is, it is your digital business card. So in here, every card is on the blockchain. So it is forever secured, we know. And since it is based on public blockchain, there won't be alterations to your data. So now that we know that, okay, so this is where I mined a transaction. So let's say if I look over this, I mean, this is barely an information that one person would understand. But let's say if I just see this keyword in my entire transaction, I know what type of transaction it was for me. So this is one of the key features which made us go with the Flow blockchain and the low transaction cost, even though, as you can see, the amount of Flow coins that I have with my ID, it's, yeah, I can see that it looks a lot low, but even with this value, I can still go ahead and have 4,000 or 3,000 more transactions with my card and there won't be any issues. So with that, I would like to end this session. If there are any questions, please go ahead.
Yeah, no, thank you, Ritvik. I think it was a good session. I hope there are questions. I don't see any questions on the chat actually. Yeah, there are no questions on the chat, so which is good. Just that on the slide that you spoke about Ethereum and Solidity. So these are basically a programming language which is developed by different providers, and every blockchain have got their preferences, and developers themselves have a different preferences for it. So Solidity is primarily used for coding things for Ethereum. So if you want to build decentralized apps or DApps as they are called on Ethereum, you can actually use Solidity as a platform to do. Similarly, we use C# as a language. You need to have skills in JavaScript and Java to actually do the other aspects of it. So it's interesting how different programming languages can be utilized. Temporary block with an example once again. So temporary blockchain, as in temporary block. So, okay. So I think if I've got your question right, Sogato, what you mean to say that every time when a transaction is done, so transaction needs to go through a confirmation. So if you remember in one of the transaction screen that Ritvik was showing, he was showing that there are 27,000 odd confirmations for a transaction. So now it's left up to you from a programming standpoint to understand how many confirmations are minimum viable confirmations that you want to leverage. So for example, if you're doing a financial transaction, and let's say if you have only 2 or 7 or 10 confirmations of that existence of that block, and that is good enough for you to change the state of your data or application, excellent. Because one of the things or one of the potential challenge that comes in specifically in a Satoshi based public blockchain is a 51% attack. So what Ritvik was trying to tell, which he has also explained in the last session, was let's say if 3 of you decide that, okay, and this is a new set of chain and we disagree, and then therefore this chain should get committed fast. So it is primarily based on the computing power that you have. So in that scenario, the transactions are discarded and the new chain that gets created becomes the final chain. So this process of block being created and confirmations being gathered and generated is where it's a temporary state. Once you commit it to the final stage and all nodes actually say that, okay, this is a final node, that's where the final confirmations comes in. So I'm assuming if that is related to that block, this is exactly what it could be. And we can, of course, take an example on a transaction basis and explain it. I think it'll take a session in itself to get into deep dive detail how exactly it works. Okay, anything else from anyone? Excellent. All right. So thank you, Ritvik. I think it was a great session, a good reference and reckoner to everything that you did. I think even on the Flow blockchain, it was previously called Florine coin, and I think which is where you were referring to. So now it was 528 characters. Now it is 1040. So there's also an upgrade that happened within the software itself, but of course it happened with the consensus of the community, and that's why it is what it is now.
Thank you, sir.
Thank you. Cool. All right. All right, guys. Thanks. Thanks a lot.
Thank you, sir.